Welcome. Welcome. Okay. Welcome back after this short break. I would like to give you a very warm welcome on our second session, which is about energy efficiency in the industry. And I'm very happy that we also have a very interesting lineup of speakers. And I would like to give the stage to the first one, which is Dr. Henning Meschede. Dr. Henning Meschede.
Yes,
oh,
hello.
Hello. Nice to see you again.
Nice to see you.
Yeah, welcome. We're very happy to have you here. I just wanted to say that you're a professor from the University of Paderborn, and I think everything else that is important will be said by you. Stage
Perfect.
is yours.
Then let me share my screen. Just give me a second. Fine. So you should now see my presentation, I guess.
Yeah, perfect.
Perfect. Then hello from my side. My name is Henning Meschede. I'm from the University of Paderborn. And yes, I'm at the Department for Energy System Technologies, which is founded in October this year. So it's a very young department, let me say. But before I started my work here in Paderborn, I worked in the same topic at the University of Kassel. So some of the case studies I will show you in the next minutes are from the work in Kassel. And I know the title is just working. The title is Energy Efficiency in Industrial Processes and Best Practices. But before we start with the best practices and the case studies, just let's spend some minutes on general thoughts on energy efficiency. So here is what we mainly discuss as an energy system. So you can open Google and just Google smart energy system or smart grid or anything else, and you see a picture like that. So somewhere in the middle is our smart city, and around it you can find all the capacities for renewable energy system, maybe some conventional power plants. Of course, the mobility sector is integrated, the energy storage, some cogeneration plants. When we talk about smart energy systems, of course, we need a smart control. And you see it down here. Often there's a small part of industrial, but the industry is mainly included as, yes, then we include industrial waste heat. And I think that's not enough. The industry sector is a very important sector when we talk about the transmission of our energy systems, and that's where we focus from this department, from our energy system technologies department. So we focus on the research question, how to involve the different sectors. What's the role of industry, of trade and commerce, of mobility, of households, where to build which capacities. So it makes a difference if we build the PV panels on our rooftop or somewhere else in the ground. And finally, we think about how do the systems look like for different regions and conditions. So there's a difference if we design an energy system for a big city like Berlin, or if we do that for rural areas. And we start thinking about energy systems by understanding the energy needs. So first of all, you have to understand why we need energy and wherefore we need energy, and then you can design the system around that needs. So you will not start and say, okay, here let's build some wind turbines, and then let's see how we can use the electricity. But first we have to think about the needs. Okay, let's talk about the role of commerce and industry for climate change. Here you see a diagram of the greenhouse gas emissions in Germany, divided by sector. So down this red thing is the energy sector, but this, it's I think it's blue, dark blue, big part, that is the industry. So you see that the industry costs a very high part, high share of the national greenhouse gas emissions in Germany. Of course, you can see the same for other countries in the world. And then on the far right of the diagram, you see our climate target for 2030, and you see that we have to reduce our greenhouse gas emissions. And until 2050, we will further reduce, or we have to further to reduce our greenhouse gas emissions. And of course, that means that we have to reduce the greenhouse gas emissions in the industry sector as well. How can we do that? We have different possibilities how to do that, but one of that possibility is increasing the energy efficiency within the industrial sector. That's one other slide to show you some general thoughts about energy efficiency. So here in this diagram, you see in this black circles the specific emissions per kilowatt hour electricity in Germany. You see that from 2000 on, we reduce the specific greenhouse gas emissions per kilowatt hour electricity from 644 grams CO2 per kilowatt hour down to 401. So why is that important? So you see that we can decrease the greenhouse gas emissions of electricity by introducing more and more renewables. Of course, renewables also cause some greenhouse gas emissions, mainly caused by the production process of these renewables and not within the operation time. And you see that we can reduce that. On the other hand, we use a lot of fossil fuels in industry, like natural gas, coal, or something like that. There we produce greenhouse gas emissions by burning them. So we produce them not in the production phase of this energy source, but in the operation phase or in the use phase. Now you can see there's a decrease in our specific emissions of the electricity, and there will be a further decrease if we implement more and more renewables. So somewhere between, let me say, 2030 and 2040, there will be a point where the specific emissions of electricity are below the specific emissions caused by burning natural gas. So they're below 201 grams CO2 per kilowatt hours, and that's exactly the time where it makes, from an environmental perspective, more sense to use electricity for heating a process than burning natural gas. And in Germany, we decided to exit our coal burning in our power supply system. So we fade off our conventional coal power plants, and if we replace the capacity by renewables, then we reach also the point where we have to exit our natural gas utilization to reach our climate targets. So the interesting point now from this diagram and from this thoughts is, from climate aspects, there's a huge difference how the energy is generated, and that means there's a huge difference which kilowatt hours we should replace, or it makes a difference if we make a process fired by natural gas, our process driven by electricity more efficient? In the beginning, I said that we have to start with the needs and the energy demand. And here you see some further diagrams from the end energy use in the German industry sector. And let's focus on the top. And here you see in this blue part that most of the end energy in the industry in Germany is process heat. So of course we have some electricity. Almost half of the German electricity, about 46%, is demanded by the industry sector. So we have a very huge part of electricity, but you can see that most end energy in industry is process heat. Electricity is mainly used for the mechanical energy, for lighting, of course for ICT, for climatization, also for providing cold. But most end energy is process heat, and that's where we have to start to reduce this big demand of process heat and the natural gas demand, which is caused by the need for process heat. We talked about the environmental aspects of energy efficiency. Of course, there are some other aspects, for sure the economic ones. So we have some interactions between the ecological, economic, and production requirements. And maybe it's more efficient, or it reduces the CO2 emissions, but it costs more money. So we have to decide which energy efficiency measures we can implement and which not. The energy costs play a certain role in the economic efficiency of the production. We see that we have, depending on the production process, share of energy costs of the gross production value between 3 and 10%. So in some sectors it's even higher, in some it's below this 3%. But in Germany, somewhere between 3 and 10% of the gross production costs are energy costs. And now, when we take the thoughts about the environmental aspects into our mind, then there's an interesting parameter, and that's the relationship between the costs of renewable electricity and the costs of fossil fuels, for example, natural gas. And this is a driver. If this ratio between the cost of renewable electricity and fossil fuels, that can decide if we implement the right energy efficiency measures that reduces our energy costs on the one hand and reduces our environmental impact of our production on the other hand. Okay, that are some general thoughts. So let's try to imagine how a holistic smart energy system design should look like. Here you see the three parts: the energy need on the left, the energy demand in the middle, and the energy supply on the right. The energy need is really what we need, why we have to drive a certain process. The energy demand is the energy we need from outside our industry. For example, in this case, we have a cooling process, for example, a cold store or something like that. So we have to ensure that the temperature within this cold store has a certain range, and therefore we have to cool it down. We do that with a electric driven compression chiller, and this causes some energy demand. We need electricity, and we get this electricity from the grid. And then on the other side of the grid, there should be somewhere energy supply, so power station, power plant, and that's our energy supply system. And now we can work on our energy efficiency on all of these three states. So for example, we can reduce our energy needs. So we can use some insulation, we can retrofit our building, we can set the correct operation points. So maybe we don't need that temperature, but it's possible to allow that the cold store has a not only minus 20, but minus 15 degrees. And that means that we can set the correct operation points of our chilling machine, and that we need less electricity to provide this temperature to the cold store. Also, we can reduce the energy demand, mainly in the way that we use efficient technologies. So in this case, we can think about replacing our chilling machine. In other cases, we can replace the pumps, the heaters, the electric drives, our lighting systems, and then we can increase the energy efficiency of that specific technologies. And of course, we can use or reuse waste heat. So once the energy is inside our industrial system, we should keep it there and use it, and not buy new electricity or new energy from outside our industrial system. And last but not least, of course, we can improve our energy supply, make it more efficient, use tree generation plants, use renewable energies. And if you see that, there's a clear direction of implementation. So we should start in the energy needs and not on the supply side. So first, reduce your energy needs, then reduce your energy demand, and finally, think about how to improve your energy supply. If you do it the other way around, then, for example, you can build a power plant which has a operating point, and then you reduce or you improve your cold store and reduce your energy need. Then maybe the measures you have done on the supply side are not longer working with that new energy need. So first, reduce your energy need, then reduce your energy demand, and then think about the energy supply. Unfortunately, of course, we have some other things we can do on the energy supply side. So we talked about using renewable energies, and then it could make sense that we want to improve some load management and make our energy need more flexible, or our energy demand more flexible. And that could mean that we have to run our system in inefficient points. But mainly you should start reducing the energy needs, then the energy demands, and then improve the energy supply. Here you see very simplified flow chart. So we have imported energy that goes to our factory or our industrial site. Some of this imported energy we directly use for running our processes, and some we use for running our so-called cross-sectional technologies like lighting, room heating, room cooling, compressed air, fresh air, and so on. We can reduce our energy needs, as seen, then we reduce our energy demand, and then we reduce our imported energy. So we can do that on the one hand when we use or reuse our waste heat. On the other hand, we can think about a decentralized energy supply within our factory. So we can directly implement some renewables like solar PV, solar thermal, some wind, even geothermal energy. And I'm very happy that the next speaker will talk about geothermal energy and the use in industrial sites. And we can also use CHP and CCHP, so cogeneration and tree generation, directly within our factory. There's still some open questions, so where to start, how to integrate, and where to stop, even when we talk about energy efficiency. So where should we start? You have seen that most of our energy is processed, and but when you now see the best case studies for energy efficiency, you will find a lot of case studies replacing the lighting system, replacing driving electric drives and pumping systems. And that's a really good point to start, so you should do that. But to get or to reach our climate targets, we should think about the processing. Where to stop? That's a further good question. So there's no end for energy efficiency. There are always some measures where you can improve your energy efficiency. So we need some benchmarks. You need some benchmarks that you see, okay, now we are in the top 10% in our industry sector in energy efficiency. Okay, there's a lot to do because we are in the lower 10%. And so we need these benchmarks and the good examples and the case studies to see what we can do and what we have to do. Furthermore, there are different points and different evaluation criterions, and that show us some different possibilities. So it makes a difference if you want to reduce your CO2 emissions or if you want to reduce your energy costs. Unfortunately, there's a difference. Maybe we can change that, for example, with carbon tax or something like that, so that reducing our energy costs will directly lead to reducing our CO2 emissions. And yes, so you see that there are a lot of different evaluation criterions, and you have to check them for yourself, then do the right measures. I will now shortly introduce to you 3 case studies. The first is about an air conditioning system, and that was a manufacturer of chocolate bars, TS transportation system, where the chocolate was transported and it was open. So they have to cool down the total hall to a certain temperature, to about 18 degrees, only for the product. So for the workers, it was too cold, but for the product, it was okay. And then we designed different measures, because the idea was that only the product has to be cooled down to 18 degrees, and in the rest of the hall, we can allow higher temperatures. And you see on the right what we have done. Encapsulation and housing. So we built something around the transportation belt, and now inside this housing we have the temperature of 18 degrees, and outside we can allow different temperatures, so higher or even colder. And that on the one hand was very energy efficient, because now we just have to cool down a smaller volume. So you see that we can save up to 50% of the energy by using this encapsulation. And on the other hand, we make the system more flexible. So in the status quo, we have to cool down the total hall to 18 degrees. And now we just have to cool down this volume to 18 degrees, and we can allow other temperatures in the hall, and there's no clear temperature. So maybe there's a range from 18 to 22 degrees. That's all okay. And that means that we can now run our HVAC system more flexible and use more renewable electricity, and see that we can reduce our carbon dioxide emissions even further. The second case study is about a chilling system. I listened to the last presentation. Never use electricity for cooling. I completely agree. So in office buildings and in households, that's a really worst solution. Unfortunately, in the industry, sometimes we have to use electricity for cooling down the systems or the processes. And this was a food processing industry. So they produce some sausage, and they have 2 chilling machines. And you see the different temperature levels here. Yeah, and the idea was that we have to measure the data, and then we can decide which chiller is the most efficient for in that situation. So we use a smart control to run to choose the right chiller for the right situation. The invest was between below 10,000 euros for the control, and you see that we have a very short payback period of 1 year, and can save a lot of money, up to 20,000 euros if we implement all the things. And the only thing was that we have to measure the data of the chiller and then to set up the right control. I talked about process heat. We have different temperatures on process heat, so that's mainly what we find, but now we can split the process heat. You see here the levels of the temperature for different processes, and you see that we have, for some processes we need very high temperature, but there are many processes with low temperature needs, and that's why we can split it up and use different forms of heat sources like renewables, solar thermal, or even waste heat. And that's my last case study. I hope I have time enough, Silke. We started a little bit later, yeah. So you see a case study from the galvanic industry. Galvanic industry means that we have a lot of baths, and some we have to heat up, some we have to cool down. It's mainly a washing process. Then we have another process, washing. Then we have the other process. And you see that we have, in this case, 3 baths, the degreasing, clearing, and condensing. So we have them, we have to heat them up. We use steam in the status quo. And then we have 2 baths, shining and oxidizing, and we have to cool them with cooling water. Of course, after a certain time, we have to replace the water. So we have wastewater of 15 degrees, and we have to refill the baths with fresh water of 25 degrees. And you see that we have a lot of, or very high heating demand of 740 kilowatts for the steam supply, and also a cooling demand of 440 kilowatts. And the idea now is that we can reuse the waste heat. So you see that we can use the waste heat or the wastewater of 50 degrees and the cooling water of 50 degrees. So once it enters the system and then it comes back, it has 50 degrees. And we can use that to preheat our fresh water and thereby reduce our heating demand of the processes. On the other hand, here in the condensing, we have very hot wastewater of 80 degrees, and we can directly use this energy to preheat our fresh water again. Yeah, we calculated all the methods, and was an invest of 70,000 euros. But you see that also here the payback period was below 2 years, and we have greenhouse gas savings of about 190 tons CO2 per year, because we can now reduce the amount of natural gas that we need. And once we did that, in the beginning I said we have first think about our energy needs, and then about our energy supply demand, and then about our energy supply. So you see here, before we did that, we have a heating demand of 740 kilowatts. After reusing waste heat, we can optimize our heating demand and reduce it to 400 kilowatts. So if you just first design your heating supply system, for example, a solar thermal plant, and you use the heating capacity of 740 kilowatts, and then you do the waste heat utilization, you see that the your solar thermal plant is somehow oversized, and that means that it gets uneconomical.
Henning, ich glaube, leider muss ich jetzt kurz.
I hurry up.
That
So
would be
you
so
see,
nice. Yeah, we're a bit behind.
These are our takeaways. The main takeaway is that start with the design of any energy system with the analysis of the needs, and in general, energy efficiency measures should start at reducing the energy needs, then reducing energy demand of processes and machines, and finally think about the energy, about efficient ways of energy supply. And last but not least, to design and evaluate energy concepts, the data is indispensable. So please think about energy monitoring and collecting all the right data. Yeah, thank you for your time. And if you have any questions, you can contact me. And yeah, thank you.
Thank you so much. Yeah, that was a wonderful presentation on energy efficiency in the industry. We also thank you for the opportunity to follow up with questions since we're running a bit late. I would like to state this to the audience. If you want to get in touch with Professor Meschede, please feel free to send him an email. You will also find the recording of this session right now in YouTube later on. So thank you, Henning. Have a nice evening. And I would like to announce the next speaker, who is our first Latin American speaker today. And this is Mr. Jose Samuel Monterroso from Guatemala. Welcome. We're so glad to have you here today.
Thank you, Silke. How many time I have it? 20 minutes?
So, yeah, 20 minutes would be awesome. So then we can maybe also have a very short question and answer session. So 20 minutes would be perfect. Thank you so much.
Okay, don't worry. Okay, hi everyone.
Okay.
Greeting from Guatemala, Central America. Start now. Okay, this is the content. We can talk about systematic energy management. The standard ISO 50,001 section about the procurement and implementation of energy efficiency project and life cycle cost. Okay. Okay. Systematic energy management. What is it? It's the use of economic and engineering principles to the control of the cost of the necessary energy necessary for the operation and building or industry to be energy efficient. Okay, this is not it's not rational. Turn off the light, turn off the air conditioner. Is use the necessary energy for the operation or building and light production. I don't know for anything or any facility. Most of the energy cost saving come from energy efficiency improvements. Some saving come from changing energy use patterns and changing energy sources. For example, a culture of energy efficiency or change the hot water with electricity or full oil, gas, I don't know, for thermal solar. Energy efficiency projects savings, low cost operation and maintenance of project with a return of less than 3 years, saving from 2 or 10%. Project with medium terms returns in 3 to 5 years, saving from 15 or 25%, and project high cost project long term returns in 6 to 10 years, saving from 25 for 40%. Okay, some barriers or external barriers in energy efficiency in Central America, in my country, Guatemala. Unstable prices in the opportunity market, spot market or price spot, institutional weakness, insufficient technical capacity, lack of financing sources. If you look in my country, there is no more or energy manager, for example, energy audit certified. There is not in Guatemala. I'm in the unique person certificate for energy manager. For example, this stability of prices, the experience and agility of the institution of the or the government to promote and control energy policies are particularly important. Once these barriers have been solved, solution will appear to increase technical capacity and obtain the necessary financing. And now internal barriers in Central America or my country, there is no trust with external personnel. It's a crazy because the people have fear to espionage. I don't know. Investment priority in the other areas more associated with the main activity, the core business. Yes, this is the huge barrier because any industrial product growing, the industrial need another transformer, another warehouse. I don't know. Investment more in the core business. Insufficient technical and economic evaluation of the energy efficient project because many industries can do it with the internal people, but the internal people don't have qualification for energy efficiency. The effort requires are not perceived as justified with the expected returns, ignorance, and desistance who makes decisions, managers, CEOs, etc. Internal resistance of those involved in the energy management when they feel evaluated and questioned in their performance and increase difficulty in the energy saving process. Okay, success energy efficiency project. Energy efficiency can be achieved in two fundamental ways, not mutually exclusive. Number one, or first, better energy management and good consumption practices in operation and maintenance. Is have a culture and take and make turn off the light when go out to my office, and when the people is in the lunch, turn off the equipment, etc. High efficient number two, high efficient technology and equipment in remodeling or existing facilities or new facilities. This is investments. The first option has a lower cost, but the results are more difficult to achieve and maintain. For example, energetic saving campaign is necessary to have someone monitoring and reporting. And this is like a foreman or supervisor, and the person becomes the most hated because the supervisor or the foreman turn off the light, turn off the air conditioner. I don't know. It's a problem for these people. The second option requires a small, medium, or large investment, but the saving potential is higher and ensure greater permanence in the results. Either of the two allows to reduce specific consumption, but the combination of both make it possible to achieve the result. In other words, make the two options. Okay, regulation and planning of energy and energy efficiency in Guatemala. We have a national energy plan. We have a plan about for expansion for generation and transmission, and we have a national plan for energy efficiency. Interested because the strategic framework of the energy policy in Guatemala have access of the energy policy, have five axes. Now, number one, electricity supply security at competitive prices. Number two, security supply oil and competitive prices, exploration and exploitation for oil reservoirs for the national supply in the future. Number four is the saving the efficient use of energy. And number five, reduction of the firewall in the country. And for this presentation is axis 4. Okay, for axis saving and efficient use of energy has operational objectives, create mechanisms for the efficient and productive use of energy, achieve that 30% of the institution of the public sector use energy efficiently, and the long-term goals encourage 20% consumption and the energy saving in the industrial and commercial sector. In other words, in the private sector. Okay. This is the what is the opportunity price or spot price in my country for the October 2020. If you look, is cheaper in my country the energy, no more to 50 $50 per megawatt hour. Okay, this is Roche. If you look Ishikawa stay all the places, you look the cause of inefficiency. All this spoon is the result low energy management. How start an energy management program? Develop an energy strategy, define objective, obtain the support for the general management director or board of directors, establish the administrative structure, record and compare the use and the cost of the energy, conduct energy audit, super important, identify, analyze, and provides the opportunities for improvement, implements energy projects, process and training, important training the people in my industry, monitor, record, set goals and report the consumption before and after the implementation of all the improvements. Energy conservation. Before execute any energy management or energy efficiency project is essential to carry out energy conservation. But what is it? Energy conservation is the reduction of the amount of the energy consumed in the system, process, organization, society, country, line production, facilities, hotel, I don't know, where is it? The economy and the elimination of the waste and the rational use. Okay, Dennis Buffington creates this pyramid. If you look first, is the energy conservation, next energy efficiency and implementation for the projects, low the energy demand, and the last, if I want to install, for example, PV in my roof, it's okay. But first, we can do it the energy conservation. Okay. Sorry. Okay. A continuous opportunity system identification is more important than the detection of the insolent opportunity. What is it? I have a example for an implementation. If you look, we have three opportunities. Um, um, First, um, in this case, the power demand is the first reduced by replacing conventional air conditioning equipment with ecological and efficiently, and following improving measure minimize energy consumption kilowatt hour by means of management in lighting and by photovoltaic system. Yeah, and another um, uh, important. Make the best effort in the installation of measuring equipment. You can manage what do you know. We can install equipment for measuring energy, thermal or electrical energy, because we can see what is the real savings. Okay. If you look in systematic energy management, systematic energy management is achieved with the energy management system quickly generate a change cost reduction with significant result. With this, just about 3 years can represent saving close to 25% of the initial cost. Yeah, it's quickly for this, but look at this. It's an energy efficient project. We look this one, but there is more. There's a heater, a water heater, electrical. Another question is, was there the systematic energy management? Was energy conservation performance? Um, Before we installing the PV, we can change this heater for a thermal solar, and we change this air conditioner. The consumption for this air conditioner is at 1 kilowatt hour. Is so much. Okay, standard 50 tons a one, section 8. Acquisition or procurement, establish and implement criteria for evaluating energy performance during the operational life when the purchase products, equipment, and services that use energy that are expected to have significant impact in the energy performance. Inform your suppliers that the energy performance is one of the evaluation criteria. Uh, uh, we have a standard this say the evaluation for energy performance for the product services and the energy. Okay, now some energy saving implementation of energy efficiency project and reduction of CO2 emissions. Okay, change electrical motor in a palm oil extraction industry. If you look, the baseline was taken the reference in the 2018 and 9 months on the 2019. The implementation was carried in October 29. This showed the replacing electrical motor older than 50 years and inefficient with high efficiency motor are attractive energy saving project, such as also reduction emission carbon dioxide or CO2. If you look, this is the saving in the bars, green bars. This one, this is the baseline. But this is the financial analysis. this is the capex, the flows, the life cycle cost is for 10 years, but in all the region of the Central America, the models has 15 or 20 years ago installation. Net present value, the IRR. If you look, the savings from the project were very attractive. The return on investment do not exceed 2 years. So the user or the end user did not hesitate to make the investment. Another one, variable frequency drive for 50 horsepower electrical motor in plastic industry. Again, the baseline and the saving. This is the financial analysis. This is very attractive because the return on investment is less than 1 year. Silke, how many times I have it?
Please take your time to just wrap up slowly. So,
okay.
Thank you.
Okay, thank you. For this case, the air compressor and it is significant, and the consumption and the investment in the installation is the variable frequency drive, and with the return of less 1 year, for which user this not heritage for the investment. This project was financed through an ESCO model for 28 months. Another one for a pharmaceutical industry. The baseline was taken the reference the 2018, and the implementation of the variable frequency drive for a 30 and 10 horsepower model, and change the 30 horsepower was carried out for the August the 2019, performing accurate analysis of equipment in the frequency of the electrical motors can vary, and by replacing an inefficient motor with the high efficiency one, attractive energy saving project can be obtained very well reductions. And if you look, the financial analysis is the net present value and the internal rate return very, very well, and this one make it the best, and the project was financed through of an ESCO model for 18 months too. The final is the life cycle cost for electrical motor. After conduct an energy audit in the mill area and this side milling industry, it was found in the electrical motor of the one of them of the 250 horsepower installed 20 years ago. Its real efficiency 82%. The mills works 20 effective hours a day for 360 days a year. The cost of the energy is the 7.5 cents per kilowatt hour, and the power is the $7.95 per kilowatt. It's proposed a change of the model of the high efficiency, 95.6%, and the same power for a value of the $22,500 installation, 350, and the annual maintenance 650. This is a real case. This is very continuous for us. The owner of the plant, in conjunction with the purchasing manager, say that the model is too expensive, and to evaluate the change with the standard efficiency, 89%, this motor value 80 tons dollar, installation 350, and maintenance 550. Before making the purchase, we do it the owner the life cycle cost analysis and the benefits for the clients, thus making the best decision. Okay, cost and saving estimate. If you look at the high efficiency standard efficiency, there is a difference, more or less the $4,000 saving calculation. There is the high efficiency, and there are the standard efficiency. If you look the final of the chart, the in only 1 year, the saving is 20,000 dollars, and the efficiency standard efficiency, 11,000 dollar. The manager of procurement, I have a trouble, but there is more. Financial analysis. If you look in the flow, there is include the maintenance for the 10 years. The high efficiency motor payback in 1.80 years, saving after 10 years, 199,000 dollars. Standard motor payback 1.75 years, save after 10 years, $108,000. The question is, which is the best option? And finish here my presentation. Thank you, Silke. Sorry for the so fast, but the time is running more. Thank you, Silke.
Time is always precious. Thank you so much, Samuel, for this very interesting presentation. I would like to ask you kind of like a wrap-up question, which is referring also to this German Latin American conference. What potential would you see for German companies with technologies of energy efficiency in the market of Guatemala?
There are many, because in Guatemala, we don't have the culture of energy efficiency. We need energy efficiency, air conditioner, electrical motors, etc., etc., etc. There are many opportunities.
Perfect. I thank you. I hope that this was maybe also like a starting point, that in the audience there's German as well as Latin American experts who would also like to follow up. I hope you would be available for questions later on. And muchas gracias. I I thank you so much for your contribution. I think it's a very important topic. Energy efficiency in the industry is important for all of us, for future generations. And I thank you a lot that you are working in this field and that you brought your perspective from Guatemala to this conference here today.
Thank you. Thank you. Y muchas gracias a todos los de habla hispana. Muchas gracias.
Muchas gracias. Ciao. So then I would like to announce our next speaker, who's also giving another Latin American perspective. So welcome, Ana Lucia Alvaro. She is the project coordinator working at the GIZ and is located in Costa Rica. Welcome. We can see your presentation. I would love you to also turn on your camera. Ana Lucia, we cannot see you or hear you. Maybe our technical support can
you hear me now?
Yeah, we can hear you now. Perfect.
Okay, great.
Oh, hello. Yeah, now I can also see you. Welcome. We're so glad to have you here. Then, since we're a bit late, I would say just the stage is yours. Don't forget to put the presentation mode, and then
just a sec.
down there. Exactly.
No. Okay. Well, first of all, thank you very much for the invitation and to share with you a little bit of our work in the Central American region. I will talk to you about geothermal. I saw in the program that yesterday you had a speaker talking a little bit on this, so it will not be so new information. But first of all, I would like maybe to share with you that the German cooperation has already 10 years working in these 6 countries in Central America. We started in 2010, and I think it was at the end of 2013 that we started to think about geothermal and what can we do to improve the use of the geothermal resources. We started with renewables in general, biogas, photovoltaic, energy efficiency, of course. But yes, we identified that there was an opportunity of promoting much more the geothermal resources in the region. We have a very blessed land here in the region, in all these countries. There is a lot of potential, and it has been only or mainly used for electricity generation. And so looking up at some other countries like Germany, of course, that use geothermal resources not only for electricity, but also for direct uses, it seemed to be a really good opportunity that we have not been using. And this is how it started, the work, and with an idea of these big opportunities that the Central American countries have, and I may say that in Latin America there is a lot of potential, not only for electricity but also for direct uses. So in 2016 we started with the work in these 6 countries with the promotion of this geothermal energy in this field based on direct uses. And we found out that a lot of people, including myself, didn't know much of these direct uses. And there was a hard work in 5 areas, 5 fields of action. And we went through them between 2006 and October of this year. We worked on regulatory frameworks within the energy ministries and secretaries of energy in the region, with the ones that were interested in getting into the direct uses of geothermal. We started to do some feasibility studies for the development of pilot projects. We did capacity building. There was a lot of need for that, a lot of knowledge to share. We also engaged the counterparts and provided spaces for exchange and dialogue in events like this. And also we tried to promote, and I think we did it successfully, to build up a regional network, because there is a lot of knowledge, and through networks you can exchange the information you have, and it's important to share it and to learn from each other. So that was the work we did in those first years, and we are starting right now. Last month we started the second phase of this cooperation project in the region. To go into details a little bit more, we are not alone. GIZ is part of the technical assistance in the region, but we work together with 2 other brothers, may say, in the German cooperation, the KfW with the financial assistance with the German Development Bank, and BGR, which is also in technical assistance like us, but more focused on the geoscientific technical assistance. They are the Natural Resources and Geoscience Research Institute. Regarding our cooperation project that I mentioned you, that is starting just right now, I may say that we are including all the 8 countries that are part of the SICA system integration in Central America and the Caribbean. We are the ones who implement this project as technical assistance, and we have 4.4 million euros for this work until October of 2023. As I mentioned before, this project will be focused on direct uses and more specifically into the use in the industry, the use of this heat in the industry. It's part of a follow-up phase of what we have done in the first years, as I mentioned. And we hope to have good examples by the end of this second phase to share on the ground with you and demonstrate the uses of this heat. Our main objective for this second phase will be to improve the conditions, the baseline and the conditions in these countries so that the direct uses, the applications really get into the ground. And how are we going to do this? How are we going to improve all this baseline? Through technical assistance, and we have 4 fields of action, which you can see here. One of them, and all of them are really important, but regulatory frameworks comes to be one of the big issues. And I think it's not only in Central America, I think it's a need in general to have to have clear with the energy ministries or the institutions that give the approval of the projects to define the field of action, clear rules. So we will continue working with the energy ministries that are interested in digging in. I can say that right now Costa Rica and Honduras are the ones that are up front in this area, which are working hard to have an act or a law or a policy focused on direct uses. But we will be willing to work with the other countries also to go forward with this. The second field, and I think it's the heart of the second phase of this project cooperation, is the assistance for implementing demonstrative projects. We are not financial assistance, but in the technical assistance, we work together hand by hand to get all the feasibility studies and all the information needed so that the financing comes. And it is really important to have these demonstrative projects working, running, because I don't know if it's something cultural or not, but when you see examples from other countries, it's really nice, but you see, it's frequent to hear from people, yeah, that works in that country or in that region, but not here. So we really need to get into the ground and have these projects working, and it's part of our work during these next years. The third field will be developing methodological tools, and this brings these tools that could help the different countries and different investors in defining the opportunities of investing in areas where the potential, the geothermal potential and the demand is. Could be specific guidelines or decision-making tools. And the fourth field, it's as in the first phase, an opportunity of exchange to have dialogue, international and regional dialogue, to exchange knowledge, experiences, and to build up this knowledge that is already in the region. Well, what are direct uses? I may share with you very briefly this slide, and very simple. What we have seen, at least in Central America, is the experience of using this heat from under the ground for electricity generation. Taking this heat, this vapor from under the ground, and with equipment, converting this heat into electricity. And there's a lot of experience within the region in this. And well, direct uses is using, as the word says, directly this heat for applications. And I will share with you afterwards some of these examples. In the first phase of our project, between 2016 and this year, we did 7 feasibility studies. And you can see here the numbers of them and the countries. We did 3 in Costa Rica. We did 1 in Honduras, 1 in El Salvador, 1 in Nicaragua, and 1 in Honduras, in Guatemala, sorry. And from these 7 studies, we had some very good results in 5 of these 7. We will be working on them in this second phase. Just here to mention just that using this type of technology, we can get into energy efficiency, but as the colleagues before speak, going into technology is not the first step we should make in terms of energy efficiency, but I just wanted to point out here that there are opportunities within geothermal also in terms of heating and cooling, and it's something that definitely we in the region would need to use, and we are not using it right now. Here are some, I mentioned some examples of how can this be, heating and cooling indoor systems could be used in swimming pools, in spas, in buildings, substituting air conditionings that are conventional and with high energy demand units, and could be substituted with heat pumps using direct use of geothermal. There are a lot of countries that already report that they use this kind of resources, but as I mentioned before, we have no experiences right now in the region, and it's nice to have the reference from other countries, but we have to have our own experiences. One of the pilot projects that we did a feasibility study during the first phase was one in Costa Rica. I just wanted to mention it a little bit. It is in Valle del Coris in Costa Rica. The main objective of this was a heating system for implementing a greenhouse to avoid natural condensation in the morning, making the plants grow more. This comes to be an issue with climate change, and we identified that this was a great opportunity for them to increase or stabilize their productivity and deal with these changes of temperature between the day and the night. Here you can see some technical information regarding the temperatures that we found in the area surrounding this warehouse. This greenhouse. And digging, making a well, which there was a well, no more than 1,000 meters from depth. We expect to develop a possible cascade use in this specific project, not only for this control of temperature, but also for dehydration and air conditioner for cold chambers, also aquaculture in the area, and eventually, why not, recreation in the area too. This cascade use is a nice example of how can we use a lot of this geothermal energy using all the ranges of temperature depending on the needs of the area. And well, in terms of CO2, it can be avoided around 148 million tons of CO2 per year if we get to develop this project. Another example is in Guatemala, in the surrounding area of the Matitlan Lake. The objective is to use some absorption chillers for cooling, 800 square meters, for fruits and vegetables. This is also a very nice example of how can we use it and to save and to protect the food that could be decomposed if they have not the right conditions. Right now this project has already a stage or a phase of dehydration working, and so the absorption chillers will be like this second phase. One part of the use of this geothermal energy, it's already taking place with dehydration, and the second phase will be where to store this fruits and vegetables in an adequate way, using absorption chillers and also the geothermal energy. It's also a cascade project in the agro-industrial area or plant. You can see there the information regarding the temperatures that are being used, and that hopefully will be used in the absorption chillers. I mentioned before that there was a big opportunity in terms of heating and cooling, not only for buildings, but also, as I mentioned with this example, in the agricultural industry. Definitely, it will really help to control temperatures, to give the adequate environment in storage, for example, and to work with systems that are climate resilient. There are also examples, very good and nice examples of these applications in the agro-industrial industry, in Turkey, in the US, in Italy, in Slovakia, in Russia. So, as I said before, it's really nice to have those examples in other countries, but we will work on to have our own examples in the region. As conclusions, and please, if you have questions, I have gone maybe very fast within the presentation. Conclusions that I may say are from our phase of working in the region these are some of them. Our countries should make much more use of existing the geothermal resources, as they are stable, are renewable, are clean, and are available. It's an available resource 24/7. Further work is needed, of course, to characterize the potential in the areas where it exists, and to identify the demand for heat in these same areas. And when I say here characterize the potential, there's a lot of work there. Geoscientific characterization of water, minerals, conductivity. There's a lot of information that needs to be identified, analyzed, to have the right signals that there is an opportunity for a development of a project. And we will be working together with BGR, our German cooperation broader project in this part in the region. Also, there are opportunities for direct use that should be widely spread, and demonstration projects, as I mentioned before, should be spread out, not only within the region, but all around internationally. It is of utmost importance to strengthen local know-how. We have been doing this, as I mentioned, but still there's a lot of work to do, and make this information known available within the region. And I think yesterday, the speaker who talked about geothermal mentioned that we already have an institution that is willing, has done a nice work and is willing to continue sharing the work and the knowledge that the region has, which is Secasier. They do have their web page and they post there a lot of activities they are doing and future activities also, and publishing information for what has been generated within the region with our help or other entities, and is part of the actors that will be working together with us in the future to spread out the work and the opportunities we have. Countries must define a clear set of rules, as I mentioned also before, for the use of this resource. And we are also giving nice steps and a lot of work in the near future. And yes, that was all what I wanted to share. And if you have any comments or questions, glad to help.
Thank you so much, Ana Lucia, for this really interesting presentation on the use of geothermal energy. As you said it before, we also had already like some words on this topic yesterday, and it's really interesting for us here in Germany to see how great the potential in Costa Rica is. Now that we learned a bit of your work, I understand that you're an expert in the cooperation between Germany and Costa Rica, as you manage two very complex programs that are connecting the two countries. And kind of as a wrap up, I would like to ask you, what would you advise German companies that have an interest in the Costa Rican market with energy solutions?
I will say not only for Costa Rica, I may say for the 6 or the 8 countries that are part of the SICA system, that there are different ways of getting in touch with the region in terms of investing in energy. And we as GIZ can be this link between them and seeking out the opportunities of investment within the countries in the region. So you can I may say that we are here to make this click between them. Mm-hmm. There are a lot of opportunities of investment and development of good and nice projects. I may say regarding specifically on geothermal technology, regarding, for example, heat pumps or adsorption chillers are examples of technology that transferring them to the region and investing in developing this type of technology, applying them in the region, it's a huge opportunity. And they should not feel alone because we are here in the region, and there are specific ways of working. One of them, directly for the private sector, are the developed PPPs, which I think Bernhard just yesterday mentioned. Mm-hmm. It's a way in which the private sector could identify opportunities of how the German corporation could work together with them to get into the region and grow a business, for example.
Perfect. Thank you. Thank you so much. I think that was like also like a very comprehensive answer with some really practical advice. And I think, yeah, thank you so much. We really appreciate your presentation. Muchas gracias. And having a very nice day. And I would like to turn then to our next speaker. So I would like to introduce Johannes Hegger, who will speak about energy efficiency in industrial buildings and give some best practice examples. Mr. Hegger, would you please turn on your camera as well? We already see your shared presentation.
Sorry, yeah.
Hello, welcome. Very nice to see you. Thank you so much for being here today. I will just leave you the stage.
Yeah, thank you very much for the introduction and for the invitation to speak to you today. Yeah, I brought you some industrial buildings that we did in the last couple of years, and yeah, let's start. So as you all know, the urban environment is growing. So nowadays in the cities, we have about 4 billion people, and this will increase until 2050 to 6.4 billion. And in the building sector, we are responsible for 36% of the CO2 emissions. So all the buildings have to do something to cope with the CO2 emissions. And in our practice, we always look on this sustainable map, as we call it. And here we have all the topics that we have to deal with. So for example, we have to look on different facade designs, if we can do something with that. We have to look at space efficiency, because our clients, a lot of the time, they just wish the space that they know. So they nowadays have 10,000 square meters, so they think they also need in the new building 10,000 square meters. But then we try to talk with them and to see if we can do it more efficient. And so we have a lot of topics that we are talking about with our clients. For example, also durability, or the usage of energy efficient building construction design, or also renewable energies. Because renewable energies are nowadays, in most parts of the world, are the cheapest energy that you can get. So nowadays, we can get solar for under 5 cents per kilowatt hour, and the trend is decreasing. The same is true for battery storage. So more and more of the also normal projects are getting PV and even battery storage. We are also looking at heat island effects, because we learned from some of the clients that the buildings that they did 20 or 30 years ago, they have problems with heat nowadays, and they have high cooling loads. So, for example, we are also looking on different roof forms and do different roof structures. And here we have a comparison between a pitched roof and a flat roof, for example, and how these roofs are getting hot over the day. So this is a thermal image in the morning. So the pitched roof is quite cool, but is also getting hot in summertime over the day. But if we are looking at the flat roof, the situation is quite different. So even if in the morning the roof is still quite hot, more than 70 degrees Celsius, and in the evening it's really hot. So you nearly only see parts above 17 degrees. But if we are looking on flat roofs with green on it, we are getting different temperatures. So you see in the morning it's quite cool, but also in the afternoon it's quite cool. And this means not only the roof is colder, but also the interior spaces and also the surrounding areas. I would like to show you 3 examples of buildings that we did in the last couple of years. The first one is a so-called solar factory from a company from Germany that's producing parts for PV, solar. And it's a factory where the company wanted to try to have a CO2 neutral running factory. So the first thing was that we covered the whole roof area in photovoltaics, but we also did a lot of skylights to have a very high quality of light in the interior and to have daylight for the workers in the inside. And also we cladded some exterior spaces for logistical reasons, but these are also covered with glass photovoltaic modules. In the interior, it's around 30,000 square meters, and it is a manufacturing plant here in the front. Then we have a testing facility and a logistical part, and they also do their own electronical assembly. At the edge, we have all the offices. So the R&D offices are quite near to the actual production facility. And this was one thing that the client wanted. And if we are looking at some of the details, it's maybe a bit more architectural driven than a normal industrial building. But you will see a comparison of the costs later on. This is the whole facility, so around a bit more than 30,000 square meters on one floor. And this is the light quality that you're getting inside. So really good daylight quality and artificial lighting also. And if we are looking on the energy concept, it's it's in the end it's quite easy, but so we have sunlight, we have the photovoltaic system, and we are feeding the different processes in the factory, and we also using biogas. This biogas is produced nearby, so it's also like a closed loop, a CO2 neutral resource. And interesting in this project was that DENA, the German energy agency, did a comparison between this building and a normal industrial building. And they found out that in the end, the energy that we are saving in this building is about 1/3, so 33%, and that we have a return on invest about 21% on the investment that we had to do on top on a normal industrial building. So a quite good return on invest because of this energy concept and the usage of photovoltaics. As a second project, I would like to show you the repair center. It's for the same company, and they planned a huge facility. So we actually only built the first phase. This is around 40,000 square meter facility, and they wanted to do like 3 times more, the 40,000 square meter module. But in the end, we only built the first phase. The design is quite, it's nearly the same like the first building, but we learned a lot from the first building, and we did a lot of the things better. So it's a quite normal floor plan for an industrial building. So we have one floor from the one side where we have the different products coming in. We have the assembly in the middle, the testing field, and the finished product comes out on the other side. And in parts, we have a second floor where the people are coming in and change clothes and so on. And the energy concept is even is nearly similar to the first one, but we also have a wind energy that we are using here. And the concept was that we have huge storage tanks for cooling and also heating that we didn't have to build in the next buildings. But yeah, we stopped with the first one so far. Really interesting for me was the construction of the roof and the facade, because here we were able to store a lot of CO2 in the construction. So we used big wooden elements in the ceiling, in the roof area, so 5 to 5.8 meters, one module, and also in the facade even bigger. So the modules were 7.5 to 10.3 meters in one piece. To do this, the construction company did a small building next to the construction site, and they built these huge modules there. So here you can see the wooden modules and how they were filled up with insulation material. These are the finished wall modules, so 10.3 meters high, and they used a normal crane to put them to the wall area and erected them like that. So actually a quite easy process, and energy-wise, or if we are looking on the CO2 footprint of this building, it was a huge step to reduce the CO2 emissions. The third project that I would like to show you is the so-called Energy Campus. It's for a company who is doing heating pumps, and this is a facility where they have offices, but they also it's a training facility. So the people who are interested in these products can come here and see all the products and use them and learn a lot about these, how to maintain them and how to install them. This facility is actually one of the first ones that was certified with the DGNB sign. So it's like a LEED or BREEAM certificate, and this is in the highest quality. It's platinum. And here we also have an energy concept. We used the roof area for solar PV, and we're using well water to produce cooling for summertime and also warm, so heating for the winter time. Here you can see a part of the roof area, so the PV and also a grass roof under it. And we also have PV modules in the south-facing facade that are also shading some of the outer spaces and also the glass facade behind it. So if we are looking on the demand and the production of electricity at this building, we see that over 1 year, actually the production side is a little bit higher than the demand side. So we have a surplus here. So over the span of 1 year, the energy that we are producing is a little bit more than what we are consuming with this building. I think in the end, in all our projects we are looking on, we have challenges, and we try to optimize especially the cooling and the heating of the building. But we have also other parts that we have to look at the different buildings that we are doing. But in most of the buildings, we are also trying to look on the life cycle. so that our clients are getting buildings that are easy and cheap to maintain, and yeah, also that we have products that are very durable, that we only have to clean them and not to exchange them. And on the other hand, if we are looking on the whole CO2 emissions that we are emitting to the world, I think we also have to look on ourselves, on our hobbies, on our traveling. And a lot of these are not dealt with very good. But in the future, I think we have to look a little bit more on these to have a chance to prevent the climate crisis. And this is so far. So if you have any questions, I would be glad to answer them.
Once again, so a little technical bug here. So thank you so much, Mr. Hager, for this very interesting presentation, for this impressive pictures also of the projects. I think it's really nice to get this, yeah, really real world examples. And I would like to wrap up this session and ask you one last So the technical bug continues. I apologize. So which services or technologies offered by German companies are, in your opinion, most useful for application in Latin America?
So at first I have to apologize. So we are not in the Latin American market. So
not yet.
Not yet. But I think we have a lot of good examples, especially for cooling products in these fields. And I think maybe there are some companies who are already in the market, and I think these are the main the main technology that we could use there.
Mm-hmm.
I mean, we have a lot of also great architects there, so we don't have to design for Latin America.
No, of course not. It's more about like kind of, yeah, encouraging the exchange. So maybe we have some architects from Latin America also in our audience that would be interested to follow up with Mr. Hager. We would encourage, of course, to build a bridge and to yeah, try to set up long-lasting relationships with our ExpoVirtual here today. So, Mr. Hager, I thank you a lot for being here in Germany. It's already quite late, so I wish you a very nice evening. You were our last speaker in this session on industrial efficiency, and so I would like to say thank you once again, Mr. Hager, and we will slowly come to an end in this session.
Thank you very much.
Okay, so I will take the last minute to say a few words for everybody who maybe also joined this session a bit later. We still would like to greet you on the next days on the ExpoVirtual Energiewende América Latina. We have a lot of exhibitors from Germany and also from Latin America that are very happy and excited to meet you at the exhibition stands. You have the chance to meet them in 5 different pavilions. So we have the Green Energy Pavilion, the Solar and Storage Pavilion, the Energy Efficiency Pavilion, one for Environment, Energy and Infrastructure, and also the Global Hub. Me and my team, we will be available also in the Global Hub, along with the German Chambers of Commerce from Latin America. And we will be very happy to see you there, but also take the chance to chat in the networking room. And as I said before, meet the German and Latin American exhibitors at their exhibition stands. So I would like to thank you for joining us here today. I think it was a very interesting session. And once again, thanks a lot to all the speakers. It was a great lineup of speakers. We feel very proud and very honored that we had so many different speakers sharing their expertise on energy efficiency. And as I said also in the introduction, I think energy efficiency is a very crucial part of a successful energy transition. And yeah, we really hope with the ExpoVirtual to put this energy transition on the international agenda once again, and to encourage further cooperations and exchange. Thank you so much, and have a nice day or a nice evening.
Bye-bye. Thank you very much.
Muchas gracias. Ciao. Ach, wie nett, sagen alle noch Tschüss.